Welcome to recording 1A in our final series for Chapter 3, this one on completing the square in Mathematics 2200. We're going to focus on creating perfect square trinomials. What exactly are they? Well, a perfect square trinomial has two identical factors. For example, x squared plus 6x plus 9 has the factors x plus 3 by x plus 3, which can be rewritten in the form x plus 3 squared because they are the same factor twice. By expanding using FOIL, or as I call it, Benny binomial to make a face, you can prove that these factors give you indeed x squared plus 6x plus 9. We can also look at perfect square trinomials from the perspective of algebra tiles. For example, if I take x squared and 5x tiles, like so, and try to arrange them with the x squared tile, I need to rotate these. So if I try to arrange them to make a perfect square, let's see what happens. Is it possible? I'm going to need to bring some more tiles in. But notice this corner down here. It's 2 by 3. So I'm going to need to fill in that corner with 2 times 3, which is 6 unit tiles, or 1 tiles. So I'll just put them in place. And it's clear that I do not form a nice perfect square here. I've got dimensions x plus 3 on this side and x plus 2 on this side. Let's see what happens with a perfect square trinomial like x squared plus 6x plus 9. So I need another x tile right here, and I need 3 more unit tiles to put in that corner. Now we have dimensions x plus 3 by x plus 3. So the two sides are the same length, and of course that forces the other two sides to be the same length, making it a square. Another item of interest here is that when we look at the number of x tiles, there are 6 of them. Half of them are distributed down here, and half of them are up here. And in this case, since we have 6 of them in total, half of 6 is 3, and 3 squared is 9. We're going to have 3 by 3 on a side here. So that's a pictorial way of looking at things. So I've recorded the side measurements on the perfect square example and the non-perfect square example here. Let's expand x plus d squared, a binomial of that form, and see what happens. When I square x plus d, I get x plus d times x plus d. Using a bit of FOIL or Benny binomial, whatever you want to call it, you wind up with x squared plus dx plus dx plus d squared. The two of these terms are the same, so you get 2 dx in the middle. That's a clue to quickly expand this example right here. So our d value in this example is 5, and following the pattern x squared plus 2, our d value is 5, so we put that in, plus 5 squared. So we've got x squared plus 10x plus 25. Notice in particular that I could use this number by taking half of it and squaring it to get the number that's at the end. Let's apply that a little bit more. This first example asks us what number has to be in the blank here. Well, first of all, we recognize that the coefficient of the x term is twice our d value. That means our d value has to be, not our x value, our d value has to be 6. Which means that d squared must be 6 squared, which is 36. That's what goes in the blank. The factors must have been, remember the factors are of the form x plus d squared. So our d is a positive 6, so it's x plus 6 squared. For the next one, our d value is negative 18. Notice it's taking that whole number along with the sign for it, so it's 2d equals negative 18. So that means our d value must be negative 9. But squaring the negative 9, we've got to square the whole thing. So that becomes positive 81. That number at the end of a perfect square trinomial must always be positive because we're squaring to get that number. Now, our factors are of the form x plus d squared, but our d value in this case is negative 9. So it's x minus 9 squared. For our final example, the middle term is negative 7, so we have negative 2d equals negative 7. That means d equals negative 7 over 2, which means d squared is equal to negative 7 over 2 squared. All we do with that is square the top and square the bottom, and we've got 49 over 4. The factors, therefore, are x minus 7 over 2 squared. In summary, a perfect square trinomial of this form, x squared plus 2dx plus d squared, has two identical factors, x plus d times x plus d. We can write those as x plus d squared. And if we want to create a perfect square trinomial when we're given the first two terms, take half the coefficient of the x term and square it. That's what we are doing here. Taking half of the negative 18, for example, and squaring it.